So this is the 2019 Chemistry Year 11 Triple Award paper. So the first question will be asking you to plot a graph. Okay, you can kind of see it nicely laid out there and labelled graph B. It then asks you to work out the maximum temperature rise. Okay, so it started at 21.5 and it ended at 28. So the difference between them two would be 6.5. You then use that temperature rise plus the total volume, okay, which would be 50, times by 4.2 equals 1365. Give a temperature reading after 2 hours, that would be 21.5 because it will return to the original temperature. There's the information to plot the graph. Make sure you do it because it doesn't look that obvious. And then it says which is the stronger of the acids is going to be hydrochloric acid because there's a higher temperature rise. Then it goes on to talk about state why using a temperature sensor would still give a lower than expected temperature rise. That's because heat would still be lost. All a temperature sensor is going to do is going to tell you more accurately how the temperature would be recorded. Suggest improvement. You could attain higher temperatures closer to the expected value. You could insulate or you could add a lid. Then, kind of a question that we practice quite a lot, name compound A. So compound A is going to be hydrochloric acid plus something. It's going to give you magnesium chloride. It's in solution, so it's going to be oxide. It's going to be magnesium because that's the start. Give the name of the blue solution B and give the gas formed in reaction 3. So blue solution is going to be copper carbonate plus hydrochloric acid. So it's going to be copper chloride plus carbon dioxide because there's the carbonate. Balanced symbol equation, then they gave you the equation for HCl. Zinc, then if you looked up on the periodic table, would be Zn. Add them together. Zinc chloride. Zinc is 2 plus, chloride is 1 minus. Okay, and then hydrogen gas plus 2. Reaction 1 was repeated with magnesium instead of zinc. Explain the difference. Zinc is less reactive than magnesium, so less H2 would be produced and there'd be a lower temperature change. Give the general formula of the alkane family. 1 mark. Nice question. Then it goes on to say give the products when alkenes and alkanes are burnt. That's going to be carbon dioxide plus oxygen. Give a structural form of propene. Propene's got 3 carbons, double bond, then hydrogens will be coming off it. Bromine water is used to distinguish between alkenes and alkanes. Describe the colour change, would be orange to colourless. Blank page. Explain why hydrogen, not sodium, is formed at the cathode. Hydrogen is less reactive than sodium, so they base it on the reactivity series. So you've got 2 chlorines would gain 2 electrons by there to become negative. That's a little bit different from how we normally do it. So we would normally do it like this. So 2Cl minus 2E goes to Cl2. Okay, but you can just use your rearranging skills to get it together. Explain why universally indicator turns purple, because alkali OH ions are formed. Sodium hydroxide is a strong alkali. What does the term reduction mean? Reduction means the gain of electrons, and I did a little half equation to show you. Over time, the solution goes from blue to colourless. State the change you would expect. C2 ions coming out of the solution are replaced. C2 concentration stays the same. And then this is a double bond, so you can see that there are 4 electrons in the middle there sharing, and then the other 4 that are already paired up in 2 oxygen molecules. Give the name of the different types of material used and describe their unusual properties. The frames have got shape memory alloys in them. Alloys because they're metals, regain shape after bending, and then the lenses have got photochromic pigment in them, changes colour with light intensity. Give an advantage of using nano titanium dioxide rather than nano large ones. They're transparent rather than white. Explain why some people are concerned about the use of nanoscale titanium. Could pass into the skin or the blood. Long-term effect unknown. Could be toxic over time. How many times bigger are they? So divide the numbers by each other. Then divide the numbers by each other to give you that answer there. Sorry, couldn't work out what's going on then. Write a balance equation for reaction 2. So reaction 2 is when carbon monoxide is formed from carbon dioxide. So carbon dioxide plus carbon gives you carbon monoxide. Describe how slag's formed. Limestone forms quicklime. Calcium carbonate forms calcium oxide. And then I put a little equation there to help you out. Balance in this equation. So the first one I noticed is ions 2. So put a 2 by there. Okay. Second thing I then noticed is that we've got 3 oxygens there. So I need a 3 by there. Okay, I've then unintentionally ended up with 6 hydrogens, 6 chlorines, so I need to put 6 by there to balance it out. Okay, when you are forming a precipitate, you're looking for the one that is the solid. Okay, so we've got 3 OH minus plus 1 Fe, 3 plus would give you that. Okay, so remember to include the numbers and state symbols, but it's always the solid you're going to do there. Loads and loads of information about tensile strength. So then on the next page is a series of questions to answer. So the first one is put a tick next to the statement that best describes one way production costs are reduced, scrap steel is used. Second one then is looking at the change between 0.0 and 0.45. Ductility decreases, tensile strength increases. Put a tick next to the appropriate value for percentage of carbon that can be included. That's 1. Name the alloy which is most easily pulled into wire and withstands the least compressive force, low carbon steel. Then a bit of a picture of the Haber process. So explain the choice of temperature used in the Haber process and the main reason why the catalyst used. High yield would be formed using a lower temperature, but that gives you a low reaction rate, so the catalyst is used to speed up rate. Balance simple equation for what's going on. So sulfuric acid plus ammonia gives you this ammonium sulfate salt. Then this is just basically a titration, but they've used some weird, not weird, but different solutions that you might not have come across before. So the first thing you need to do is place sulfuric acid in the burette, measure 25 centimetres cubed of ammonium hydroxide into a conical flask, add a few drops of the indicator, add acid steadily until we reach end point, record the volume of acid needed to reach end point. Okay, then you repeat without the indicator, remove water, evaporate to form crystals, because it said to make pure crystals there. Blank page. Okay, 2 advantages of using method A. Sugarcane is a raw material which is sustainable, low pressure, so cheaper to operate. Disadvantage, batch process, slow, labour intensive, carbon dioxide is formed, which has an effect on global warming. Balance symbol equation then, so it says that they form water, so take H2 out of that, and then the rest of it would be left to form ethanoic acid. Nice exothermic thermic question, so bond needed to break the 1 mole, okay, so you've got the 5161, which is the total reactants, okay. 1 mole of methanol is 2061. There were 2 moles of methanol, okay, so take 2 of them away from that, you're left with 1495, divide by 3 to give you 1 O bond. Okay, then you need to work out the products, which is exactly the same format, and then for this bit here you had to do reactants, take away products would have given you exothermic, okay, and then draw an energy profile by that. Give the letter of the isomer corresponding to each letter, so butan 1-ol, the OH is on the 1, it's going to be C, butan 2-ol, that one there, 2-methyl propanol, so propan 1-ol, it's that one there, 1, and then propan 2-ol, it's going to be that one there, propan. Look at the number of carbons. Use information to give the chemical names for each of the components. So compound A is going to be iron because it forms a green precipitate, and then it gives off a reaction with barium chloride, which represents sulfate ion. Next one then is this red litmus paper turns blue, so it's going to be ammonia, and it's also fission, so it's carbonate. And then C gives off an apple green flame, which gives you barium, and then cream precipitate, which is chloride. Then it says calculate the number of moles of lead nitrate. So you've got, this is really easy, there's your volume, there's your concentration, just be careful to divide that by 1,000, and that gives you the number of moles. Okay, then it asks you to work out the mass of solid lead nitrate, so work out the MR. Okay, you know the moles because you just worked it out there, times it by the MR, rearrange the equation, gives you the mass. Okay, how much lead nitrate should the technician weigh out to ensure that the concentration of solution is close as possible to 0.25 moles per decimeter cubed? Like the nearest next figure, so round it up slightly, so 20.69. Okay, extra space if you need it, extra space if you need it, table of ions, and a periodic table.